I'm thinking that the difference in speed is just due to the difference in size of the input shaft, of the output shaft, and this shaft. The output shaft of the overdrive, if you will. So yeah, so basically right now we have 3 shafts. We have the input shaft, just from here to here, goes to the engine. We have the main shaft, that's what they call it in the manual. The manual transmissions cars, there's just 2 shafts. Manual shaft, main shaft here is the output shaft. So there's just the input shaft and the output shaft. Because drive shaft, remember that long pipe that goes to the differential on the wheels in the back? That's called the drive shaft. It's connected directly to this here. Now here we have an extra shaft, which is this shaft. So we have 3 shafts. Now this shaft, instead of it being connected to the main shaft, it's connected to the outer. It's connected to the outer portion, the circumference of the rollers here. It is connected to the main shaft when the teeth here are locked. Okay, but when the teeth aren't locked, it's connected to this, so you have an automatic transmission. Now the thing is here, you see. So if we consider, let's study how the gear size is here. So here's the shaft right inside here. So the small shaft, the small gear, going to a slightly bigger gear, which then goes to an even bigger gear. So basically right now we have a really fast output, but then it gets reduced again, you see? It gets reduced again. So like here it's turning very fast, but here it's turning a lot slower. But I will say that this shaft here is still slightly bigger than this shaft. So this here will actually turn faster than this here. On the outside, we're not talking about RPMs now. We're not talking about rotational speed. We're talking about the outer speed. Because whereas before it was getting, in the manual transmission cars, just manual, the drive shaft is connected to the shaft. So the outside, the circumferential speed is not applicable. But here, like I said a couple of times already, the drive shaft, the output shaft, instead of being connected to the shaft itself, it's connected to the outer portion, the circumferential portion of a gear, which is a lot faster than the center. Remember, the shaft is at the center. So by connecting the output shaft to the outer portion of the gear instead of the shaft, it allows the output shaft to turn a lot faster and automatically. Okay? But the thing is, like I was saying, if you do that, but then you reduce the gear again, then it's going slower again. So, but still, it's not, mechanically and in terms of driving, it's a huge difference. But mechanically, visually, it's not too easy to see. And I'll show you why, but this is making sense now. Now remember the radios we had for reverse. Remember, this is reverse and first. We had a 3/3 to 1 radio and a 2.5 to 1 radio. So let's say 2.5. This here is the second gear for the second gear, and you'll see that their size visually, it doesn't seem to be a huge difference. There's third gear there. You could actually even confuse it with the second gear. You see, smaller, medium, bigger, smaller, slightly bigger, bigger. But considering that, and for the first gear, we had a 1-to-1 radio, And for here we had a 3.12 radio. So you sort of think that this gear would be, just zoom out a little. You'd sort of think that this gear would be 3 times, bigger than that one, but it's not. I mean, in terms of circumference, it probably is, but visually, it doesn't. I mean, it's obviously not 3 times bigger than that one. So small difference in gear size, but the thing is, it's spread out in a circle, right? So a little bit longer on one side and on the other side. So for example, if the diameter is if the radius is 1 centimeter bigger, the diameter is actually 2 centimeters bigger, and the circumference is probably quite a bit more. It's not directly proportional, if you understand what I mean. So for the radio to be 3 times larger, the diameter is not 3 times larger. It's only, I don't know, a little bit larger. So that's what I'm thinking here. Yeah, that is certainly the case. So that's the only thing that was sort of confusing me, because I was sort of looking at that and I said, well, they made the gear bigger, but then they brought it down to the same size again. So there's no change in speed. But it's not. It's actually a little bit bigger. And that little bit bigger is probably going to give all the difference. If we really wanted to make this even faster, more overdrive, I could make this shaft here bigger. I'd put a wider drive shaft, and then the drive shaft would turn even faster. So the overdrive, actually, it only adds 1 gear, but it's not through a gear. It's just through the size of the shaft. See, that's the catch here. It's actually through the size of the shaft. I mean, through the gear, obviously, as well, but it's through the increasing the diameter of the shaft. And I mean, the shaft is actually the same as the manual drive shaft, but the key difference here is, instead of the output shaft being connected to the shaft, which is turning at the same speed as the engine. Remember, the shaft is in a 1-to-1 radio, but remember, the circumferential speed is turning faster than the input shaft. So if I were to put my finger here on the outside of this gear, whichever gear, they're all turning a lot faster than the input shaft of the engine. So by doing that, by changing that, they're actually taking taking the advantage of the outside speed of the gear, instead of connecting the output shaft to the shaft, which is smaller and turns slower. Guys, this is genial. This is just genius work here. No gears, no fancy nothing, no synchro mesh, nothing. This is truly amazing. Now the only thing left to discuss is the cable. Okay. Oh yeah, I forgot. I said I was going to talk about how the bicycle works. And the way the bicycle works is it's got lots of like hook-shaped teeth, and that they move. So when the chain is going that way, you see it's pushing the teeth, the hook down away from it. So the chain is, it's freewheeling there. But when the chain is going the opposite way, now you see it hooks on the hook and it engages that gear. You see? It's getting caught on the hook now. Right? Like that. If it goes that way, the hook is pointing down. If it goes that way now, towards the hook, see, it's engaging the hook. Let's say if it was like this, not like that, you see? Engaging the hook. I mean, the best way is for you to actually open up a bike and see it. But here's the same thing, but instead of a hook, it's just pressure, frictional pressure, which is truly amazing. But this, by the way, is also the weakest part of the transmission. So let's say you're in first gear and you just, hit the gas without disengaging the overdrive, then it's just gonna be bad, right? So it's not for drag racing. Okay? If you hit it, if you put in the first gear, hit the gas, and for whatever reason you're not in overdrive, I mean you are in overdrive. Now if you hit the first gear and you have these massive, and power is going through these massive pinion gears, then I mean it's not a big deal. But if you hit the gas and you're in first gear, you're going through this here, it's going to be too much torque. Remember, in first gear there's a lot of torque, but I mean if the car is stopped, then you also have a lot of available speed from the engine, right? Because the engine is revving up really quickly. So you could easily damage this. But I mean, what I can do is, if for whatever reason you damage these rollers, what's going to happen is you'll damage the rollers. You might, I don't think so, but you might damage the inside wall here. But I'm thinking, I should think that the inside wall is harder to damage. Anyways, it's thicker for that reason. That this is going to wear out, right? This is the part that wears out faster than the others. I mean, only if you don't know how to drive, if you do this that I'm saying, right? But what you can do is, instead of buying these ones, which are probably expensive, what you can do is you can measure them. I'll give you the measurement here right now. They're actually, let me see, 0.8 millimeters. They're exactly 8 millimeters, guys. They're exactly 8 millimeters. So what you can do is, instead of buying, them like that, you can just find a long bar that's 8 millimeter in diameter and cut these. Just cut them to size. That's all there are, little cylinders. I mean, you will have to use a high grade steel or maybe even stainless steel with high nickel content. Because if you just put soft steel in there, I doubt that you'll get very far. It's just going to wear out quickly. So you need to have, really high steel with high carbon content, or stainless steel, which is even harder, I believe. Okay, but that's your option there. It's 8 millimeters wide. There's 12 of them. You only need a little piece. If you buy them separately, I mean, they'll obviously be the correct grade steel, and they'll be the correct width as well. But I mean, if you want to save money and save time, for whatever reason yours are damaged, just go to the metal supplier and tell them you need an 8 millimeter rod, or cylindrical rod, not a construction rebar. They should have it, and it has to be in high. You have to tell them that it's got to be high grade steel or stainless steel. Now, for what I'm pretty sure they have it already in these sizes, but I mean, you could, if for whatever reason you're unable to find that diameter, you could take it to a machine shop and tell them that, right? But 8 millimeters, I'm absolutely certain I've seen these around. Then you just get the bar, cut the pieces you need, put them in, that's it. You're good. Oh fuck, I put this in the wrong place. Well, the only thing that's left to discuss is the function of the it's called the locking pawl source. Sun gear control plate. Remember that gear with lots of like big teeth? That was called the sun gear locking plate. Okay? And what it does is right now when the overdrive is disengaged, when the overdrive is engaged and the sun gear is inside, see, it's just turning freely, and the I'll have to turn it around here. I have to change angles here. Let me get a pencil. Now pay attention to that darker, this is what I'm talking about, this gear here. Remember, it's a weird shaped gear. In the middle there's teeth that mesh with the teeth of the sun gear, this gear here in the middle. Now when the overdrive is engaged, you'll see that this gear here, the plate, the sun gear control plate gear, is not spinning. It's still meshed, it's still connected to the sun gear, but the sun gear is not connected to anything. Now, the instant that I pull this out, push the sun gear into the inside of the pinions, now you can see you can clearly see that hang on, I forgot the name. Jesus Christ. My sakes. Well, I was looking something up. The sun gear control plate is actually turning with the sun gear and with everything else. You actually see it turning. Yeah, you can see it turning there. See these little holes here? See it turning. Oh, there, you can clearly see it now. See that hole there? This is the gear that I'm talking about, right at the tip of the pencil. It's a really thick pencil, mechanical pencil, by the way, 2 millimeters thick. See, that's the sun gear control plate. Now it actually adds friction. You'll see that it's considerably harder to turn the shaft if that thing is connected like that. So the manual transmission is actually, in terms of hand, I'm turning it by hand, so it is a little harder. But in terms of the engine, that's nothing, right? But I just initially thought, wow, that's kind of weird. Is it supposed to be like that? It is supposed to be like that, guys. In fact, if you don't have any friction at all, then you have a problem. That's what it says in the manual, right? Now, so what we still have, before anything else, before I forget, see this dent here? This dent here is for the manual lever here. Right now overdrive is disabled. You push this in, overdrive is enabled. So what this lever does here, it's the overdrive mechanically disables the overdrive. So it'll be here like this, and in your dash, remember in the dash control, there's an overdrive control in the dash. manual. It's a steel cable, just like your parking brakes. You'll push this. You see, here's the hole. As you pull it out, towards you, you're pulling it. The overdrive control cable, it's going to pull this, which is going to push that outwards, like that. And it's going to lock these gears here, the pinion gears. Remember? See, now they're locked, they're not turning. See, they're all stationary, they're not turning at all. Watch the difference. See? Overdrive enabled, overdrive disabled. Overdrive enabled, see? Overdrive disabled. Pay attention to this little gear here. It's called the pinion. See, it's not turning. When the overdrive is locked out, that's what they mean by locked out. For me, sometimes I'm not familiar with these terms and say, well, the overdrive's locked out. Okay, what does that exactly mean? Right? Is the overdrive like turned off? Why don't you just say turn off, turned off? And I mean, this is I noticed that this is automatic, so I was thinking, well, does it turn off both gears or just one gear? But it's actually just one gear. I initially thought that the overdrive would add two gears, but it's actually only one gear. Okay. Still, I mean, it'll add 3 speeds because you'll have like before with the 3-speed manual, you'd had first, second, and third. Now, because you have these here, they're automatic. You can engage the overdrive. So you're in first, and then it'll go faster in overdrive, and you'll have first overdrive. But you're not really supposed to use first overdrive. I mean, if you use it gently, I'm sure you can. But most people, they'll just floor it, and I've seen a lot of people saying that they have used it for years, overdrive in first gear. Others say that you shouldn't use it in first gear. I mean, as long as, like I said, as long as you don't fucking hit the gas and just, push the fucking hell out of the torque in this thing, then, shouldn't be a big deal. And the worst that's going to happen is you're going to ruin the little bearings, and I mean, you might as well ruin this here. But I mean, if you're going nice and slow, that shouldn't happen. But if it does, I've seen these for sale. They are expensive, but I mean, nothing compared to modern transmission, guys. Modern transmissions, I know a guy, he paid $2,000 for them, not for a new transmission, not for a used transmission, just to change the fucking seals. Just to change the seals in the transmission. Okay? This here, I mean, worst case scenario, you take some measurements, take this to the machine shop, they're going to charge you, I don't know, let's say it's $300. If you buy this off of the internet, it should be, I don't know, 100, 150 something, around that. Nothing close to $1,000, nothing close to that. I doubt that you'll find any modern transmission for under $1,000. I doubt it. That's nothing even close to 500. So to get this. So, but what this does here, once again, going back to the lever, this pushes this out like that. You see, and now it's mechanical. The overdrive is disabled, and you have 3-speed manual. Okay. And it doesn't matter what the solenoid does, the governor does. This mechanical device here is locking this in. Now, that being said, you really shouldn't do this if you're on the highway. You're going at, 100 kilometers, 130 kilometers an hour. Then you suddenly decide, well, I'm going to put it in 3-speed manual, and you do that. That's probably not good. It's just going to change the power from here to there, but it's going to force the engine. So it's not good to do that. Right? Anyways, it's probably not going to destroy it right away, but it's not good. So once again, another sort of doubt that I had was, you know, you have that knob. Do you push it? Do you pull it out towards you to engage the overdrive? Because that's what I would think. Normally, you have to change. You have to push something out in order to engage it. For example, you have to push out the parking cable. You have to pull it in towards you to engage the parking cable. You have to pull out the cigarette lighter to get the lighter. So, you know, in order to activate things, you have to change them from the state that they are currently in, like from their normal state. If you sort of just follow me. But with the overdrive, it's the opposite. If the overdrive is close to the dash, if it's pushed in, then it's activated. In order to deactivate it, you know, to disable it, to shut it off, you have to pull it towards you. Okay, pull it out, thereby increasing the distance of the knob from the dash. Okay. That wasn't very well explained anywhere I've seen, or you know, it might just be my ignorance, but I just would like to explain that. So that's again what it does. You know, locks it out, you know, shuts it off mechanically. You know, these things are, you see, they're mechanical. That's why they last so fucking long. They last forever. If it was electrical, forget about it. Fucking sensors, fucking switches, fucking this, fucking that, all fucked up. Okay, now we can move on to the part that I believe it's a little more complicated. Actually, I will end the video here because it's almost half hour already. So, once again, let's just recap for the following video. We will discuss the function of the solenoid which goes through here. It's just a piston basically that goes forward and backward. Solenoid, the sun gear locking plate, which is that plate right in there. Let's see how close we can go. Pretty close. Right there, right at the tip of the pencil. It has this little hole here. See, 3 of these holes at equal distances from each other. That's probably for the oil to get in through here. And like I said, it causes friction. It has a like a big ring around it. Ring, and it's shaped. It's got sort of like a horn shape at the end. On the manual, it is called, and this is the Borg-Warner manual, by the way. You know, every manufacturer that used the manual, they had, perhaps they had slightly different terms, I'm not sure. I know they had like slightly different shapes for the cases, for the housings. So what I'm talking about now is the retainer plate with oil cuff. And the oil cuff is just a little cup of oil that's right underneath. You should be able to see it from the previous video, but it's not important. I mean, it's just the oil. It's like a little spout for the oil. But what we're talking about, the important parts now, are the solenoid. We're going to discuss in the next video. Solenoid that goes here. The sun gear control plate, and the I'm just going to call it sun gear ring. Okay, and obviously the governor, which goes on the housing, like right there. Oh yeah, there's the other switch here. There's a switch right at the end. Here, right at the end. There's this switch here that would go right at the end here, like that. It just pushes it forward inside, forward and in, like that. You see? I doubt that this switch is working. So we just gotta discuss that.